In this video, we're going to be looking at the concept of price elasticity of demand. So we'll discuss what PED is, examine price elastic and inelastic demand, look at some of the factors affecting PED, and run through some calculations. Finally, we'll also look at some of the implications of PED for different economic agents. Demand refers to the quantity of a good or service that consumers are able and willing to buy in a given period. Demand follows the law of demand, which explains that if the price of a good goes up, the quantity of it demanded by consumers goes down, and vice versa. In other words, price and quantity demanded have an inverse relationship, leading to the downward sloping demand curve we're all familiar with. So from the law of demand, we know that in general, price hikes will lead quantity demanded to fall. But by how much will it fall? This is the question price elasticity of demand seeks to answer. Price elasticity of demand is defined as a measure of the responsiveness of the quantity demanded of a good to changes in price. This formula shows how it's calculated. It's the percentage change in the quantity demanded of a good over the percentage change in its price. In shorthand, you can write this as the percentage change in QD over the percentage change in P. There are three main types of PED you should be aware of: price inelastic demand, price elastic demand, and unit price elastic demand. We'll come on to two other extreme forms later on in the video. Price inelastic demand is when the quantity demanded of a good is relatively unresponsive to price changes. This means that any percentage change in the price of a good will lead to a smaller percentage change in the quantity demanded by consumers. A key idea is that PED figures will always be negative. This is due to the inverse relationship between price and quantity demanded. Any percentage increase in P will lead to a percentage decrease in QD, and any percentage decrease in P will lead to a percentage increase in QD. After omitting this negative sign, goods with price inelastic demand will have a PED value that's less than 1. Examples of such goods include petrol, diesel, cigarettes, and alcohol. Hopefully it makes sense why the quantity demanded of these goods isn't going to change that much in response to price changes. Regardless of price rises, people will still probably need to buy petrol and diesel so they can get to work in their cars. And since cigarettes and alcohol are quite addictive, a small price hike won't stop the majority of people from consuming them. The demand curve for goods with price inelastic demand is quite steep, almost vertical. As you can see, this means that any change in price will lead to a smaller change in quantity demanded. Price elastic demand is when the quantity demanded of a good is responsive to price changes. This means that any percentage change in the price of a good will lead to a larger percentage change in the quantity demanded by consumers. Again, omitting the negative sign that's always present with PED values, goods with price elastic demand will have a PED value that's greater than 1. Examples of goods with price elastic demand include canned fruit and brands of breakfast cereals. If the price of one brand of cereal goes up, you have a vast array of cheaper alternatives to choose from. This means that the quantity demanded of the more expensive cereal is likely to fall considerably. The demand curve for goods with price elastic demand is quite shallow, almost horizontal. As you can see, this means that any change in price will lead to a larger change in quantity demanded. Unit price elastic demand or unitary price elastic demand is a halfway house between price inelastic demand and price elastic demand. It occurs when a percentage change in price leads to an equally large or proportional change in quantity demanded. As a result, goods with unit price elastic demand have a PED value of 1. There aren't many real-life examples of such goods. This is more of a theoretical concept, but worth noting down nonetheless. Here's a demand curve showing unit price elastic demand. You can tell this because the price change leads to a proportional change in quantity demanded. As mentioned earlier, there are two extreme forms of PED. These are when the demand curves are perfectly horizontal or perfectly vertical. The first diagram shows the demand curve of a good with perfectly price elastic demand. The PED value here would be infinite, as increasing prices, even by a little bit, would cause demand to collapse completely. Goods with perfectly price elastic demand are more likely to be seen in perfectly competitive markets, where consumers have perfect information on all firms' prices. For example, if you have two stalls selling a glass of lemonade for £1, then as soon as one of the stalls raises prices to £1.10, everyone will go to the cheaper stall, and demand for the more expensive lemonade will collapse. The second diagram shows the demand curve of a good with perfectly price inelastic demand. The PED value here would be 0, as any price change, no matter how big or small, will not affect quantity demanded. One example of such a good would be a life-saving medicine. Regardless of the cost, people in need of that medicine will buy it. Here's a summary of the 5 types of PED we have covered so far. Here's a typical question asking you to work out the PED value of a good. Pause the video here if you want to work through this question before we get to the answer. So as the formula for percentage change is the change over the original value multiplied by 100, this is the form our answer is going to take. The question states that the quantity of smartphones demanded fell from 3 million last year to 2 million this year. This means that the original value is 3 million and the change is minus 1 million. And we're going to multiply that by 100. The question also states that prices went up from £100 last year to £200 this year. So that's a £100 increase from an original value of £100. And we're going to multiply that by 100 as well. Putting this into a calculator, we end up with a value of minus 0.3 recurring, which we can round down to the final answer of minus 0.3. As the PED value without the negative sign is less than 1, we can infer that the demand for these smartphones is price inelastic. There are 4 main factors that determine whether the demand for a good is price elastic or price inelastic. These 4 are the availability of substitutes, addictiveness or brand loyalty, time, and the share of income spent on the good. We'll go through each of these now. The demand for a good becomes more price elastic if that good has many substitutes. This is because price hikes will just incentivize consumers to buy those substitute goods instead. Quantity demanded will fall considerably as a result, leading to a higher PED value. On the other hand, a good with very few substitutes can keep hold of consumers even after price rises, and this leads to price inelastic demand. The life-saving medicine is a good example of this. The fact that there were no other options for treatment meant that demand was perfectly price inelastic. The number of substitutes a good has obviously depends on how that good is defined. For example, peas in isolation have lots of substitutes, such as carrots and sweet corn, but vegetables as a whole don't have many. So the demand for peas will likely be price elastic, and the demand for vegetables would likely be price inelastic. Addictiveness towards a good and brand loyalty are major factors contributing to price inelastic demand. This is because they make consumers put up with higher prices, forcing them to spend more overall rather than getting them to cut back on the amount they buy. Tobacco and alcohol are key examples of goods you can become addicted to, and the demand for iPhones is relatively price inelastic due to the considerable brand loyalty Apple benefits from. Time is also an important factor to consider. In the long run, demand tends to become more price elastic, as habits, addictions, and loyalties can disappear or change over time. This allows consumers to consider substitute goods more seriously, meaning that price rises in the long run are more likely to convince shoppers to look elsewhere. The share of an individual's income spent on a good can also have an impact on PED. Consumers spend a relatively low proportion of their income on goods such as soft drinks and snacks. This means that small price rises aren't likely to have any meaningful impact on a consumer's ability to buy other goods and services. This convinces consumers to look past the price hikes and consume the same amount of the good as before, meaning that quantity demanded becomes relatively unresponsive to price changes. The failure of the UK sugar tax to bring about a large decrease in sugar consumption can be explained using the concept of PED. The tax led to an average price hike of 10 to 20p for most sugary soft drinks. For most consumers, 20p is tiny relative to their income, so the tax was met with price inelastic demand. This is why the tax didn't have the intended effect of reducing the quantity of sugary drinks consumed in the UK. Let's now take a look at the impact of price elasticity of demand on a firm's decision making. The objective of most private firms is to maximize profit, so a firm's decisions are going to be centered around a goal of increasing profit levels. If a firm knows that demand for its goods is price inelastic, it knows that increasing prices will not lead to a large percentage fall in quantity demanded, so it may make sense for them to increase prices. The opposite is true for firms selling price elastic goods, in which case there's going to be an incentive to lower prices. In both cases, making these decisions actually increases a firm's total revenue, and by extension their profit levels, as we'll see on the next slide. Analyzing PED also incentivizes firms to advertise their products. In order to be able to raise prices, total revenue and profits, firms would need to make demand for their goods price inelastic, and they can do this through advertising to increase brand loyalty. So in the case where demand is price elastic, raising prices is going to reduce total revenue from the area shaded red to the area shaded orange. This isn't going to be in the firm's interest, so it would be better off lowering prices rather than raising them. However, when demand is price inelastic, raising prices does benefit the firm, as total revenue increases from the yellow area to the green area. Finally, price elasticity of demand can have an impact on government's decision making. For example, if a firm wants to tax a good or service with negative externalities in order to reduce the consumption or production of that good and benefit society as a whole, the effectiveness of that policy move depends on how price elastic the demand for the good in question is. In the case where demand is price elastic, even a small tax encourages consumers to consider cheaper alternatives. If the tax was on driving, for example, consumers would be considering using bikes and public transport instead. This makes the tax hugely successful in reducing the negative externalities linked with the good being taxed. However, if the demand for the good is price inelastic, the impact of the tax, even a large one, is going to be more muted. The same goes for subsidies to encourage the consumption and production of goods with positive externalities. Their effectiveness depends on the product's PED. As you can see, the fall in price due to the producer subsidy leads to a large rise in quantity demanded for the subsidized good with price elastic demand. This is because the good becomes much more attractive compared to other substitutes, driving consumers away from buying those substitute goods and towards buying the subsidized one. On the other hand, the subsidy isn't going to make much of an impact if demand is price inelastic, and this may be because consumers don't need to buy more of the good, so most won't increase their consumption of it regardless of the price. Again, going back to the example of the life-saving medicine, if patients only need 1 vial a year, then a fall in price isn't going to make patients buy 2 vials a year. The second vial just wouldn't be necessary. We've reached the end of the video now. Here's a news article and some accompanying questions related to PED. Thank you very much for watching.